And welcome to episode 18 for the mathsonlinetuition.com videos, where we're going through C2 Chapter 2. We're going to continue with 2.5 from the trigonometric identities chapter. So 2.5 says that as follows: you can use the cosine rule to find an unknown angle in a triangle if you know the lengths of all three sides. So if you know A, B and C, okay, then you can find an angle from these quantities, okay, and using the formula, which depending on which angle you want to find is useful. Okay, so in this particular case, let's say this is A, this is B, and this is C, and we have A, B, C here. Okay, so in this particular situation, if we know, let's say this is 8, let's say this is 4, let's say this is 6, okay, let's make this 7 actually, then all you'd need to do is you would say B is 7 squared plus 6 squared plus 8 squared over 2, and then you remember, if we're trying to find A here, then you'd miss out the length A when it comes to multiplying in the denominator. So we would have 7 and we would have 6, okay, and whatever the answer would be cos A. Okay, so that's a very simple technique to use. Now if we progress through, you can see that example 12 goes through a similar thing. You have all the three lengths, and again you get the answer, and you do the inverse to get the angle. Same thing here, okay, that you can go through. Examples, exercises, three lengths, all of them, figure it out. Very simple, very straightforward. Now 2.6, you need to be able to use the sine rule, the cosine rule, and the trigonometric ratios sine, cos, and tan, and Pythagoras theorem to solve problems. In triangle work involving trigonometric calculations, the following strategy might help you. When the triangle is right-angled or isosceles, it is better to use sine, cosine, tangent, or Pythagoras theorem. So we have sine A equals A over B, cos A over C over B, tan A over C. Okay, straightforward, simple. That's the sine equation. Now if you want to appreciate cos, the cosine rule, sorry, alright, as is stipulated there, you have two lengths, okay, plus angle between them, or you have three sides. Lengths, sides, interchangeable, so that shouldn't be a problem for you to grasp. With the sine, okay, we've already mentioned before that if you're trying to find the length, then for example A, you need to have its opposite angle A and length B, and likewise for the cos A and tan. These are all the trigonometric ratios, okay, and this is another way of finding the missing data that you require for the subsequent workings out. And obviously we have the Pythagoras rule, which is very important over here. So in this particular example, you have a set of information, and now you can start to get into the routine of trying to guess which formula you're going to use, which rule you're going to use. So I have 3 lengths here and I've got no angles. Okay, it's asking me to find an angle. Okay, that's going to be cosine. Alright, so this is the kind of thing that you want to start running through your mind. Also, here is another example of using the sine rule. Okay, I've got the sine rule here, and then I've plugged in the 2 values. I know what A is from using the cosine rule, and then I can find out, okay, what C is, and then obviously you can find out what B is. So these are using 3 different methods, sorry, 2 different methods, the cosine rule and the sine rule, to find all of the sines, like all of the angles. Here's another exercise, some more exercises for you to do. You can calculate the area of a triangle using the formula. What does that mean? So let's write out, so the area of a triangle, okay, half AB sine C, or we have half AC sine B, or we can also have half BC sine A. Okay, what does this mean? Well, it's very simple. If we want to know the area of a triangle, and let's follow the way it's been documented in the book, CAB, then we want to tell ourselves, or we want to find out what the area is. Then we can use any one of these 3 formulas. Okay, so it shows you here, show that the area of this triangle is half AB sine C. So what it's done is it's taken all the values in unknown form. Okay, that's a right angle, that's a right angle, and it's essentially said, right, if we have a half A, which in this case is going to be, so if we just go back to our previous example, okay, so if we have, say for example, A, and then the length H, okay, and then we say H is also equal to B sine C, okay, then we've got 2 different equations, and we can substitute H in place for B sine C. Sorry, we can substitute B sine C in place of H in this equation to get equals half AB sine C. So look what we've done here. We've said a half, okay, multiplied by A multiplied by H. Where do we get that from? Well, if we say that the area of a triangle is half times base times height, okay, so we have the half times the base. So in this particular example here, they've used this as the base for the first triangle, so that will give us A, and then they've said H, which is the height here, okay, you can see that's H, right, and then they've said that's 1, and then that was with regards to this part of the triangle. Now let's try to find this part of the triangle. So again, we can say half times the base, okay, and then again you can say that the base is going to be B, as it denoted, sorry, the base is going to be yes, B, and then we know that, sorry, let me just clear this page. The area of a triangle is half times base times height. So we figured out how we got 1. Okay, and then if we use the sine ratio, sine C equals HB, okay, that means that we will have this brought up there. So we have H equals sine CB. This is again the sine ratio as was denoted above from the ratios, if you recall, the cosine A, B, C, and then tan A, B, C, okay, from the other examples which we had above. And then we add the two equations, so we have equation 1 and equation 2, okay, this being equation 2, and we have obviously from our base times height, then we get that half AB sine C by substitution. Okay, apologies for that earlier kerfuffle. Sometimes you make mistakes, but as long as you can resolve them straight away, that's the main thing. Work out the area of the triangle shown below. Same thing here, look what you have, two lengths and an angle. So you ask yourself, okay, which one can I utilize to find the area? And we know that we can utilize the formula which we were given above. In this situation, you can ask yourself now, okay, which rule can I use? Can you use cosine? Can you use sine? And that's going to be your challenge to start to identify these things. Again, find the length of the longest side, AC. Okay, sorry, find the angle. Same question posed to you. Which would we use to find? So we have the area. So we know the area is AB of ABC is 12, and so then we have sine x degrees equals 12 over 15, if I'm not mistaken. I think that says 12 over 15, and then we can get this value here, and then obviously not invert it, sorry, but to the power of -1. And then calculating the following triangles. Here we have the mixed exercises and the summary of key points. So I'll make a fine statement here, which is, this is very important for you to note. If you remember in the beginning, I said that this is a bit lengthy of a chapter for the simple reason that it's not difficult to apprehend. There's a lot of formulas here, so of course we had, just to outline them for you to remember, we had the ratio of trig identities, identities, yep, okay, and then we had, so obviously we had the cos, we had the sine, we had the tan, okay, and then we had the Pythagoras, okay, and then a squared plus, okay, 6 squared, and then obviously we had alongside that the sine rule plus its criteria, and then we had the cos rule plus its criteria, and then we had the different rules with regards to sine rule when looking for the length or angle, and then cos rule when looking for length or angle. Okay, so this is just a brief outline of what's written here in more detail. Please do learn this. So thank you very much. That's the end of chapter 2. In our next video we'll progress on to chapter 3. Thank you very much for listening and take care.